Hello and welcome everybody. Thank you for joining us for Let's Talk AI, how AI models work and are built. My name is Dakota Nunley. I'm the Content Strategy Manager here at Udacity, and I'm very excited to be joined today by our very own Sofia Lemons. Sofia is the Senior Technical Content Developer at Udacity, where she's led and launched a number of cutting-edge AI courses. She's also a published AI researcher and brings 10 years of tech and computing education to the team. Sofia, thanks for joining me today.
Thank you, Dakota.
All right, well, I'd love to kick things off at the beginning, as they would say. I'd love to just get an idea of your background and journey into the field of AI and programming. What inspired you to pursue this career?
Yeah, so I think I first got into understanding computers and working with computers pretty young. I was fixing gaming systems with my dad when I was really young, so I got into the idea that you could take a thing apart and really try to get to know how it works inside and fix it or change it. As for AI, when I was moving from undergrad to grad school, I got really interested in the idea of solving really big problems that have huge amounts of possibilities, huge amounts of data, anything in that vein. So my area that I studied the most in was AI planning algorithms, things like how Google Maps helps you navigate from point A to point B, or how UPS schedules their trucks. But I really enjoy anything that has that big space of possibilities that we really need to narrow down to what's important in that space.
Love that. Lots of big problems nowadays that AI is helping cause and solve, it seems like, but mostly solve. At a high level, I'd love to get an understanding, what is an AI model and how would you explain it to someone new to the field or someone on the fringes of the field?
There's a bit of work we have to do around kind of figuring out what we mean by a model, especially today in AI. Really, a model is just a way of viewing the world and of focusing on the details that are important for the problem you're trying to solve. So sometimes we provide a computer with a model. Like in a navigation problem, we might provide it the roads and the speed limits on those roads and some traffic information, and that tells it what's important and what to focus on. When we get into things like machine learning or deep learning, there we're talking about the computer doing more of the work of discovering that model, taking some mathematical pattern and using the systems that it has available to make connections and to be able to learn to solve problems after building its own model in that space. But again, ultimately, those things like neural networks or stuff like that just really help the computer to understand what information to focus on in relation to each other. We may pay attention to this aspect at some times and this aspect at other times. That's all what the model helps to inform.
Perfect. And you had mentioned navigation. I'm curious, what are some real world applications of AI models that people interact with either daily or weekly or on a regular basis?
Sure. So if we're talking about especially those models that the computer has learned, machine learning type of models, things like voice recognition or when you can speak to a device and it responds to the words that you're using, that's because it's learned some model for what different words sound like and which ones are likely to follow each other. When you get recommendations from something like your video streaming platform or things like that, those are based on a model that system has learned about the relationships between people and the content that they consume. Things like fraud detection as well, when your bank can tell that something looks like your normal spending or doesn't look like your normal spending. It's got some learned information in the background there of how people's spending patterns typically go and how much they might range from time to time. And then when you're talking about more generative models, then you have lots of applications in terms of creating text for customer interactions through like a chatbot, generating images, or helping people write code or other content as well.
Can you walk us through with that in mind, what are the basic steps involved in building an AI model, whether from scratch or built on something else?
Yeah, well, the really most important fundamental step is understanding the problem that you're trying to solve. Because, as I mentioned before, the model's going to have to help the computer to focus on what's important in the problem that it's looking at. And you, as the designer, the engineer, the programmer, are going to need to know the details of that problem inside and out well enough to be able to choose the right kind of approach for the computer to build a model or be given a model, to be able to know what amount of data or information you might need to have in order to solve that problem. So really clearly defining your problem is an important first step. Then, if you're going to be building a model through machine learning, then you have to prepare data for that computer to use and train on to be able to build its model, and then decide on the type of model that is appropriate to your problem. Maybe a simple neural network might solve the problem. Maybe you need some sort of deep neural network or a decision tree to be able to categorize information. And then once you've chosen the right model that actually is fitted well to your problem, then you can train the model using the data that you've given it and see whether you were actually correct in that being a good model by evaluating it using some testing data to measure things like accuracy for it or how well it performs the task that's been given to it. And then from there, you can either go back to previous steps because your model isn't doing what you needed at all and it turns out that the patterns in your data just aren't well represented there, or move forward into deploying that model and putting it into some larger application to do the full task it really needs to do.
In terms, you had mentioned data preparation and data in general. What role does data play in AI models, and why is it so important to get that aspect right in this? I imagine from the beginning of picking the model that will solve your problem, as you'd mentioned, and moving forward.
Ultimately, the two most important things in machine learning and in AI are the data and choosing the appropriate model to be able to do what you need with that data. So if you don't have enough data, if you don't have the right kind of data, or if you don't process it and prepare it properly, you end up with terrible results because the job of the data is to inform the model and help it to train. You think about if it sees only bad examples or only a very limited amount of what might be possible, that when it is put out into the real world to solve actual problems, it will not know what to do because it hasn't seen that problem before. It will give bad responses because it only saw bad responses before. Or if it was not given enough information, it might not even have really been able to fully form the patterns in its structure that it needed to be able to solve problems with that. Some other issues you can run into are bias in the data, for example. If the things that you've given to it are leaning in one particular direction more than they would in the wider world, then you end up with a model that believes only that direction of possibility or more strongly in that direction than reality would dictate. The other thing that I wanted to mention is that just getting the data is not always enough, that for the types of models that you might choose, there are specific things you might need to do to make the data ready, converting it from one type to another, scaling it so that it doesn't weigh this feature more strongly than that feature because of the fact that the numbers just happen to be bigger here. You know, people's income is usually higher than their height, but that doesn't necessarily mean it's more important for determining what size of clothing you should offer to them on your website. So knowing how to shape that data is another really important aspect of building a model.
And in terms of the models themselves, I'm curious, what are the key differences between machine learning models and deep learning models, and what are some best practices or even just protocols or ideas on how to select which for which problem?
The differences between machine learning and deep learning are sort of in complexity of the job that you are asking the computer to do, or in other words, how much structure you're providing in advance versus how much you're relying on the machine to discover the structure for itself. So, for instance, decision trees are very strictly structured as this split up tree kind of data structure to them. And that provides the computer with some information about how it's allowed to approach that problem, and it fits it into that model, and therefore can also face some limitations from what it's able to represent that way. Similarly, for linear regression problems, you might use a simpler model because you know the fact that your problem can be solved linearly with something that only learns that particular type of relationship. When you've got more complex relationships between the data and you need to rely on the computer to discover those complex relationships in the data, things like detecting objects in images, which is not something you can perfectly structure and tell it exactly where to look for where a ball might be and the full set of what colors a ball could be or what patterns could be on it. It needs to learn a large scope of relationships for what does the ball look like in a picture, where might it be likely to be in that picture, and so on. Then you can rely on deep learning, which is really just using neural networks with many different layers to them so that each layer allows sort of a more greater possibility of discovering a new set of relationships. And the more of them you have, the more complex of a relationship it can potentially represent. But then going back to that data problem, the more data you're likely to need, and the more you're going to really want to evaluate how effective it actually is on the problems that you are trying to solve, because it will need to see many, many examples of the problem, such as that speech example we talked about before. It needs to hear many, many different samples of what speech is like and what words those match to, or otherwise it's going to learn a very limited scope. And that's where you get things like the systems that tell you they can't understand what you're saying when you're saying very simple things, because it hasn't learned that pattern, possibly through lack of data or possibly through other design issues.
Very helpful. Related there, which tools and frameworks are commonly used to build AI models today? And it could be those you mentioned or more generally.
It's certainly a pretty broad landscape, and especially when it comes to generative AI models, it's really quickly evolving there. But if we talk about thinking of machine learning, sort of more traditional machine learning algorithms and approaches, or deep learning, for the more traditional machine learning algorithms, scikit-learn in Python is a really popular library for using those models. For the deep learning kind of approaches, then TensorFlow and PyTorch are very popular, sometimes also for things like natural language processing. Though for kind of contemporary natural language processing, things like GPTs and LLMs and stuff like that, the Hugging Face library, and especially the transformers components of it, are really popular for doing that kind of model building.
Yeah, thanks, Sophia. If we step back, I know you had mentioned data as a key piece here, but how do you measure the performance of an AI model, and what makes an AI model, I'll use air quotes, good or bad?
When it comes to evaluating a model, it can really vary a lot in terms of what kind of model that you are working with, and particularly what kind of problem you're trying to solve. For example, for classification tasks, like where we have lots of examples that we do know the classification for, and we'd like to be able to predict that classification for new things that we haven't seen before, we get a large set of samples for it, such as, here is an image I know contains a ball, and here is an image that I know does not contain a ball. And we can train the model on some of those, then use some of them to evaluate it once it's trained and see how well it predicts those and measure its accuracy in that way. For Other models where we're solving problems that we don't already have a clear-cut answer for, we may need to look to other evaluation methods to try to really understand how well they're doing. One of the big things that often comes into consideration in evaluating AI models is the concept of fairness, in the sense of if something falls into a particular space of what we might be observing, are we more or less likely to assign it this outcome than we would be to other examples. Some ways that we sometimes talk about this are things like the likelihood of a false positive versus a false negative and things like that, because if we are more inclined to have one of those types of errors in the ways that we are predicting things from a model, then it could lead to really negative outcomes for actual people, actual systems where we're deploying that model. And then when it comes to generative AI models, it can be even more complex to evaluate their quality because of the fact that they are generating something new and unseen before, and we don't necessarily have something to compare it against. So we use other measurements like perplexity that talks about the likelihood of the results it comes out with based on its original input data, that allows us to say, okay, is it at least a bit coherent based on the examples that we know it's seen in the past? And that helps us to evaluate if that model is really learning patterns within that data.
As a follow-up there, what are some of the biggest challenges faced when deploying AI models within real-world applications specifically?
Certainly, one of the biggest ones is just being able to make sure that it can scale to the size that you're actually attempting to use it at. Even asking for a result from a really large neural net or from a large language model or things like that can take a very long time, regardless of whether you've trained it or not before. And so making sure that things are set up to be efficient when they're faced with actual large-scale real-world data is one really important challenge when you're deploying an AI model. I kind of mentioned before, but things like bias and fairness and ensuring that even if you didn't have perfectly well-distributed data going in, you have looked at the results, you have tweaked or fine-tuned or done whatever is necessary to ensure that it will actually be fair and unbiased to the best of your ability when it comes out with results is an important step. And then one of the other biggest problems that we're seeing, especially in the space of generative models, is the fact that the data that it might have used can become outdated so quickly. If you ask for facts from something like an LLM, it will only be based on the data that it had at the time it was training. Or if you are talking about some new programming technique and trying to get assistance with debugging that, if that's new enough and the model hasn't been trained on that, it may give you incorrect answers to those sorts of problems.
And in terms of the ethical concerns and biases, you had mentioned a few, but I'm curious, how do developers address those in AI models today?
I think one of the biggest and most important first questions to ask is, should we be relying on an AI model to make this kind of decision or to be in this kind of, process? That can sometimes be handled simply by asking that question in advance and saying, in fact, no, we want to be really careful here and we don't want to deploy an AI solution to this. It can also be addressed with including humans in the loop on that and having some human oversight once the model's in place. Yes, it can come up with its own result, but a human can pay attention to it and say, actually, those are not the kinds of instructions that we want to give out to clients for, fixing or repairing our appliances that we sell or things like that. So no, we're not going to let that result out the door. A human can QA it and check it and make sure it's actually decent. You also can do auditing of AI solutions. This is especially common in the sort of like machine learning and classification kind of things that you can look at categories that you suspect might be related to bias in the data, especially if, say, that data came from a real-world situation in which there's known to be historical bias in it or that sort of thing. You can explicitly look at the results as they come out along the lines of where that bias might be likely to fall, and you can examine those sorts of things like the likelihood of a false positive, the likelihood of a false negative, or the likelihood of, given this external circumstance, how much more likely are we to classify it as A rather than B, or that sort of thing, because there's a lot of intrinsic or implied information inside of the data that we feed to models that we would need to draw out in doing that kind of auditing and bias detection for it. One last thing I'll mention is the more explainable that we make our models, the more that they put their own reasoning forth or are able to be sort of examined and explained in what they're doing, then the more transparent we can be and the more we can observe when there is something unethical or biased going on in the model.
Lots of great problems to solve for folks watching who want to get interested and build their own AI models. A long way to go, but we've come a long way as well. I'd love to wrap up here, Sofia. What advice would you give someone who wants to start learning how to build their AI models?
I think a couple of things. One that I think is really the most important is find a task or a project or something that actually excites you and that you're interested in that you might be able to apply an AI solution to. You can learn about the different approaches like machine learning, deep learning, generative AI, and then look for a problem that fits well to one of those and use it to kind of motivate yourself through doing this work, because it takes a lot of study if you want to do it well. So once you have that motivation, that sort of idea of what things you could do with AI and what sorts of problems you could solve, then you can go in and learn the technical tools that you need to use AI models. And some of those might involve programming languages like Python and some of the machine learning concepts of what is a neural net or a large language model or things like that. But there are many tools available that you can start in at a low code or no code kind of level too, depending again on what kind of problems you're trying to solve. And then because those tools are constantly evolving and constantly changing, getting hooked in with resources of where you can learn the news and the latest information about what things are developing in AI is an important way to be able to make sure that what you're actually studying and working toward is still currently the right tool for the job.
Great stuff. All right. Well, thank you so much, Sofia, for the time and insights today. And a big thanks for everybody for stopping by. No matter what your professional goals are, we hoped you uncovered some valuable insights during this discussion. And if you want to forge your future in tech and AI, be sure to like, comment, and subscribe to the Udacity YouTube channel so you don't miss any of our upcoming content. We're going to be publishing a lot of great stuff for you. Thanks for watching, and we'll see you next time.